All right. So, hello, welcome. This presentation is containers on RouterOS. So, how to run containers on RouterOS and when does it actually make sense? Because routers are not what you commonly associate with containers. So, we are not just going to do some technical demo that's way out there just for the technicality of it. We actually want some common use cases and something that will be useful. So let's see if we can find something that works. Yeah, that seems to work as well. All right. So who am I? My name is Tomas. I'm the team lead at Unimes. I've been a system and network architect for 20 years at this point. I especially like automation and monitoring. That's what I specialize in. I'm a ex-MikroTik trainer, ex-MikroTik consultant. I've done a lot over the years. As you see, I'm with Unimes. So Unimes is a network configuration management system. I won't talk about us. If you are interested, we have a booth down there. Come and talk to me. So this is just for people finding this later. A lot of my presentations make it on the internet, and the talk is always more interesting. So all of my talks are there if you're ever interested. All right, let's go. Did I forget? Yeah, I think we flew past the intro. So let's go. Containers. And first of all, yeah, isn't this Docker? Wasn't the presentation called Docker and MikroTik? What is the difference? And I have to say it was a lie. I lied to you because everybody knows Docker, but maybe not everybody knows containers. So let's talk about what is the actual difference. What is a container? So in this presentation, we will be talking about containers, actually Linux containers, but that's not a single thing, really. There is Docker, there is LXC, there is Podman, and then there is much more. And these are actually not the same things, but they are Linux containers. So what are Linux containers then? Well, define a container. Linux container is just a set of one or more processes that are isolated from the rest of the system. That's it. Think of it kind of like a virtual machine. It is not a virtual machine, but think of it like a VM, except you aren't running a whole operating system, just a single application isolated in a container. And yeah, so simply, it's an entity isolated from the main host, but sharing the main host's resources. It is much more efficient than a VM because you aren't running a whole operating system. It's inheriting and sharing the kernel and many other things, but is completely isolated from the host. And yeah, can you be more technical about that? Yeah, sure. So actually, what makes containers possible on Linux are namespaces. And namespaces are just a way to isolate a process within the container from the host and other containers. And specifically, those are the PID, so process ID namespace, network namespace, bound namespace, etc., etc. There's a bunch of them. Then there are control groups or C groups, which actually limit and allocate resources to containers from the host. There are union file systems, which just allow containers to use an isolated overlay file system. And then there is the container runtime, which is responsible for managing the container. So it's a bunch of technology in the Linux kernel and in the generic Linux GNU ecosystem that allow you to run a fully isolated entity within Linux itself. So we will be using this. So what about RouterOS then? Well, RouterOS provides an OCI container compliant implementation. What does that mean? That just means you can run the same containers as Docker, LXC, Podman, etc. on RouterOS on MikroTik. We actually don't know what RouterOS is running under the hood to provide container support. MikroTik has never specified, although LXC is highly suspected because it is a common technology. But there actually hasn't been a confirmation from MikroTik directly what they are using for their containerization. Okay, yeah, so why is this useful? Why should I, as a networking person, care? Well, it's just another useful tool in the tool belt. As you know, MikroTik is, the power of MikroTik is that you can do many things. And many of those might or might not be useful, but you can do them. And containers are just another one of those things that are very useful in specific cases, but not useful in others, just as any other technology. And so why and when is this useful? Well, specifically because it allows you to reduce hardware and centralize services. So fewer failure points, less power draw, which might be important if you are running somewhere on solar, on battery power, less things to manage, less things to break, less things to replace. So you have to deploy a router anyway. So why not use it to its full potential? And so yeah, throughout this presentation, we will be talking about what are those valid use cases, how I have used containers in the past, and when not to use containers. All right, so yeah. And hopefully by the end of this presentation, you will see that this is a useful tool, and perhaps once, when you need it, it is there waiting for you, and you can use it. All right, so let's talk about hardware. Okay, all right, that sounds interesting. I'm intrigued. What do I need to run these containers? Well, container support is available in RouterOS on ARM64/Ampere-based hardware. So CCR 2000 series, RB5009, HexAP, etc., HexAX, sorry, HEP-AX. And so actually, throughout this presentation, we have a little lab here. We have a CRS 304, the 10 gigabit switch. We have a 5009, and we have a HEP-AX. And so throughout this presentation, we'll be running about 15 containers across all of this infrastructure, providing various services. But you can also run it on containers on CHR, which is super nice, because if you are deploying CHR, you likely have a lot of CPU power, a lot of RAM, etc. And if it's running in there, then yeah, sure, you can deploy containers. You can also run containers on older ARM, 32-bit, you could say. Not really, ARM is a generic term. To be specific, ARM v6, ARM v7, ARM v8 CPUs. But be careful with the resources. And these are things like RB1100 AHX4, L009, the 4011, etc. But be careful here because so these are various architectures of CPUs, as you likely know. Not all containers are available for all architectures. It's the same as with RouterOS. When you deploy RouterOS, you have to download the right RouterOS package for the right architecture. Container also has to have a package for the right architecture. Just about everything is available for ARM64 and for x86, or x64, sorry. But not everything is available for older ARM. And technically, you can run containers on x86, MikroTik's older PC, however you want to call it, RouterOS distribution, but realistically, no, because almost no containers are available for 32-bit systems anymore. All right. Oh yeah, there's this new monster thing that came out, the RDS 2216. This presentation is very well timed. And so yeah, this is a containerization monster where you can easily run like about 50 services with the resources available on this thing. So this is completely new from MikroTik. I know a few distributors already have it in stock. But yeah, 16 CPU cores, 32 gigs of RAM, a bunch of storage, ideal to deploy containers on. All right, so yeah, what do you actually need? Well, from software side, RouterOS version 7, the newer, the better. This lab is running on 7.18.1, so the latest RouterOS version, specifically because there is a /31 support, finally fully available in RouterOS. We'll be using that. So yeah, the newer, the better. So what do you need per container? Well, about 50 to 200 megabytes of RAM per container. This very much depends on the service. We will have services here that take literally 20 megabytes of RAM. We will have services running here that take 200 megabytes of RAM. So it depends. Then you need some CPU power. And again, how much depends on what the container does. Lightweight containers will use just about no CPU. As you can imagine, pushing 2 to 3 gigabytes of traffic from the container will fully max out the CPU. It will be one of the things we will be doing. And then there is mandatory, you must have storage. So some USB stick that will provide storage, because the MMC flash that's on routers is first of all slow, and second of all, not suitable for a lot of read and write cycles. And so we don't want to burn that flash, so a mandatory, just any old USB stick, 8 gigs will do. All right, so can you give me an example? Sure, we just mentioned that we will have a 5009 running here. This has 4 CPU cores, 1 gig of RAM, will easily run 2 to 4 containers, depending on the use case, depending on what those containers you use, and will max out at about 2 gigabytes of traffic using iPerf in a container. That will max out the CPU. So that's not a little. So it can do even these are, as you can imagine, RouterOS is running on top of Linux. So these are really general purpose ARM computers just running routers. So we'll just be using them as general purpose computers. But they can do some serious CPU lifting even with this power available in your router. All right, so how do you deploy a container? Well, let's talk about some container basics. So container images need to be pulled from a registry, or an image needs to be provided manually. So to run a container, you need an image. The important part is that containers are immutable and revert to the image state after each container restart. So we have an image that serves as a, you could say, template of the container. And yeah, if you stop a container, run a container again, it will be back to the state of the image. So for example, if you run a pure, clean Ubuntu container and apt install curl, restart the container, the curl is gone. And yeah, this is great for security because it means whatever happens to your container, you just cycle it and it's back to the original state. This is also great because you cannot really break a container. Asterisk, you can break anything if you try hard enough. But the point is you can just cycle the container and it will be back to the original well-known good state. But this means also we need to deal with data persistent differently, because if we want to store some data, we just said that container restart will revert the container to the image state, which means persisting data inside of a container itself is not really possible. And we will look at how. There's a very easy way. We'll see how to do that. All right, so pulling images. So there are many registries. We mentioned you need to pull an image from a registry. There's a Docker Hub, there's GitHub, there's Microsoft registry, there's so many of them. And so to pull an image, you need an image reference. So for example, here is an image reference for Pi-hole, a ad blocking DNS server software. We will be deploying one of those in a short while. And so here I have a fully qualified image reference. And that image reference we can see here is actually built from a registry. Let's do this. So this is our, there we go. So this is our registry part right here. So we see this one we are pulling from docker.io, which is Docker's Docker Hub registry. Then we have a namespace right here, and we have a repository right here. And you can see for Pi-hole, these are the same thing, really, just Pi-hole, Pi-hole. And then you have a tag, and that tag, in most cases, is used to specify which version of the container, of the image you are pulling. So this is a fully qualified image reference, but really, most of the time you aren't going to use that. Come on, thank you. So let's talk about how these references behave. Oh, we lost. Oh. We are back. All right. So all of these that you see here are actually valid image references. So what is happening here? So if we just say Ubuntu, what we are doing is actually specifying. All right, come on. Oh, no, we don't want to do any of that. We are actually specifying the repository here. So just saying Ubuntu specifies repository without a namespace. So there can definitely be images without a namespace, but this is tightly controlled. So only the most well-known and established organizations like Ubuntu, like Debian, etc., actually have images, repositories without the namespace. They exist, it is not common. Then we have here a repository with a version. So we are saying pull Ubuntu 2204. Then we have Pi-hole/Pi-hole, which we have actually looked here. So now we are using a namespace and a repository. All right, so, but okay, you mentioned that the previous ones don't have a namespace. So what is happening there? So actually there are defaults for everything. So if you don't specify something, it uses a default. So what is the default? So for repository, you have to, for registry, you have to specify what is the default registry if it's not specified. For namespace, the registry decides what to use as a default if the namespace is not specified. And for the tag, the repository decides what is the default if the tag is not specified. I hope that kind of made sense. It's like an inheritance structure. When if you specify just the repository, the rest of it is inherited. All right, so Pi-hole, and then we have a much more common, so this is the most common format you will see, where we are specifying the repository with the namespace, where that comes from, and with the version. This is the most common format of a container identifier you will see. And then finally, we have a registry, namespace, and version. Sorry, there's a registry here, there's the namespace, that's the repository, that's the version. So a fully qualified one. And here you can see that we are going from GitHub container repository. I know that's a bit confusing, and I hope it makes sense. This is why I'm spending so much time on this is because this is what most people get confused on. Like, why do I just have a single word? How does it, why when I have two words? What is all of this? So I'm hoping you at least get a sense of how this behaves. And I'm hoping that makes a bit of sense of what we are going to do and when we use all of these identifiers. All right. Oh my God, so much theory. Can we do something practical? Absolutely. So now that we've gone through all of that, let's do something fun. Let's do a network engineer's version of Hello World. So what is a network engineer's version of Hello World? Well, how about we do a speed test from a container? All right, so we'll deploy a speed test container on our MikroTik, and we'll do a speed test, a little Hello World. So let's start with some preparation. So we need to prepare our router to be able to run containers. So we need to do a one-time setup for every router that's going to run containers. And what we are going to do there is we are going to deploy the container package, enable the container capability, and then prepare our mandatory USB stick. So let's do those 3 steps. So, all right. From this point on, we are going to do a lot of labbing. As you likely know, things like to break during live labs. Anybody would like to offer a sacrifice to the live lab gods before we start? Well, I stole a USB stick from Ron earlier today under the guise that I need to borrow it. So we'll now sacrifice that for, no, I'm just kidding. Yeah, I'll submit it to the raffle, thank you. All right, so let's do some labbing. So all right, let's disconnect from the access point. All right, we have a router here, so this is our, can you see that okay? I hope it's a little bit small, but, sorry? All right, let's zoom this in. All right. Is that any better? Let's see, is that okay? All right, so we have our 509 here. We'll connect to it. All right, hello, MikroTik. So I just want to show you that this is a fairly standard MikroTik. So let's do export. Is that big enough? Should we do one more plus on the size? One more? All right, let's do one more. All right. One more for good measure. Is that okay? One more? All right, most people think that's fine. All right, so this is nothing crazy. It's not much config on here. So we just have some bridge, some ports in the bridge, a DHCP pool, a DHCP server, ports in a bridge, IP address, DHCP client for the WAN, and that's really some DNS, some little firewalling just so you don't hack my lab while I'm playing here. And then there's a net. So there is nothing special here. It's just a very small edge router 5009. All right, so let's start messing around. So we said we need to deploy a container. Sorry? All right. Maybe we'll do one more plus for good measure. All right. One more? Okay, all right. So let's deploy, we said we need to do 3 things, right? We need to deploy the container package, enable container capability, and deal with storage. So the first step, here we go. The first step is get the container package. All right, so here is the CLI stuff, which you can just paste it in and it will do, but I'll show you manually just so you have an idea. So we just go to system, packages, where's my packages? Here. We do a check for updates. All right, that will load the available packages here, and we just do container, enable our package, and do apply change. All right, so the router will reboot. That's fine. We have a minute before that does. It's stuff. It's magic. And so now we need to talk about device mode. So device mode is a new thing that was introduced, I think, a year ago, or maybe more, maybe 2-3 years ago at this point. But device mode is basically a security measure that prevents things running, more advanced things which could be abused from running on a router. As you likely know, a lot of people tend to get a new MikroTik, they reset it to the default configuration, and then put it on a public address, because why not? And so it doesn't have a firewall, and then they wonder why somebody breaks into it. And yeah, so MikroTik has decided that this is big enough of an issue, where MikroTik introduced device mode, which limits the things you can do on your router. And one of those things, since containers are extremely powerful and they can be used for good and bad purposes, by default, containers are not allowed. So we need to set the container device mode for containers. All right, let's do that. Hopefully, our package is installed. Come on, Tik, you can do this. Don't break on me at the beginning. There we go. All right. So let's check our packages here. Let's check our packages here. All right, what's going on here? Can we? Yeah, all right, well, this is starting out well. It's because the USB stick stayed intact. Yeah, this seems good. So. Okay, well. What's going on here? We can see the neighbors. Okay, you know what? Let's see if, it just needed to be scared that we are going to use older Winbox. All right, we are so back. All right, we see we have our container package enabled now, and it's working. And from now on, we are going to be scaring the new Winbox with the old Winbox, because that apparently worked. All right, so we have our container package enabled, and now we need to enable our container feature. So you see, I've just pasted in this device mode, and it's telling us that we need to power off the router or reboot it by pressing a button. So why is this a thing? Because if you could just enable this with a command, then it wouldn't be security at all. So you need to prove you have physical access to the device to enable the container capability. So I'm gonna physically press a button on our MikroTik, bam, which will reboot it again and enable containerization support finally. All right. So you will need to do this one-time setup on every MikroTik you want to use containers on. Just be aware of that. All right. So while that's rebooting again, let's see. What's thereafter? All right. We said we need to prepare our storage. So I just stuck a random USB drive in there. So we want to format it. And we also want to prepare some directories. So we will prepare 2 directories, actually, on the storage. And so you see here, we'll create a container pool directory, and we'll create a containers directory. And we'll talk in a second after it reboots about why we need the 2 and how they behave, and we will actually see live how data move between them and why each of them is useful. All right, so let's check if our MikroTik is back, or if we need to scare it again with old Winbox. Not yet. All right, there it is. See, it's actually behaving now. All right, so let's check our system device mode. Print. And container, where are you? Container, yes. All right. So we can now deploy containers on this MikroTik. All right, so let's copy our commands here. So we'll just format this, copy, new terminal, paste. All right, it's formatting. There we go. Our flash drive is ready. Come on. I have a backup of everything, literally. if it's needed, we'll use it. All right, and let's create our 2 container directories. Got it. Okay, so we can move on. All right, so now we need to set up some defaults. If you remember, we mentioned that a container will use a default registry if we don't specify a registry in the container reference. So here we are going to go to container config and set our default registry. We'll be using Docker Hub. And then we will set a temporary directory to the USB, to the directory on the USB flash drive we just created. You'll see what it does in just a sec. So we'll go here, paste that in. All right, got it. And now, finally, let's do our hello world. So here is a bunch of config. Don't worry about this for now. We are going to explain this. And so we just take this, paste it into our MikroTik, do an enter, and magic happens. So what is happening now? All right, let me show you. So first of all, we go into containers, and we see that our container is here, and the status is extracting. So if we check our files, what is happening now, actually, MikroTik is pulling this container from our registry. You can see here it's actually downloading the image, and it is extracting the image from the temporary download location into the location of the container itself. I hope that makes sense. So yeah, that just finished. And by the way, there are very good logs for everything. So if we open logs here, you can actually see it was all of the time it was pulling that image. It was showing us, oh, I'm pulling this layer, I'm doing this, I'm doing that. And here it told us, import successful, container is ready. So it took, you can see it was very fast. It took like 20 seconds. And so now we have a container here, which is in a stop status. So let's just start it. All right, our container, status running. So let's check our hello world. Oh, look, we have a speed test. Let's do this. And as you can see, this is on my local network on a port 3000. And let's do a speed test. All right, there we go. It's slow. Why is it slow? Because I'm connecting over Wi-Fi. So yeah, obviously on Wi-Fi, this will be not the greatest speed. But that's okay. So actually, I tested this beforehand, and doing a speed test at a full gig from this container consumes about 30% of CPU on the 5009. So it's not that bad. The 5009 can do 2 to 3 gigabits of traffic from a container on the router. All right, so yeah, that's our network engineers equivalent of hello world, doing a speed test from a container on a MikroTik. All right, so yeah, so what was all of that? Like there was a bunch of networking stuff. So let's talk about what we actually just did. So as you can see here, we set up a virtual Ethernet interface, and then we set up an IP address, and then we executed container. We are adding a new container. The root directory will be on our flash drive in the containers directory. Then we have a remote image, and you can see that reference here. We are referencing open speed test latest, semicolon latest. So how this works is, this is the namespace. So open speed test, their registry is called latest, just so it's confusing, and the version is latest. And then we are assigning this container to our virtual Ethernet interface that we created. All right, so let's talk about how that works. How does networking work with RouterOS with containers? So here is our lab topology, actually. So you can see a layer 1 topology or a wiring diagram is very, very simple. We just have the internet, our 5009, 10 gigabit CRS, and a HAP AX2. Simple. And for the L3 equivalent, all we have, so our 5009 is doing NAT to the internet, and then we have a single local subnet with our switch and with our access point. Standard home small network, or single office network deployment. Very, very simple. All right, so we are adding a container to this somehow. So how? What did we just do? Well, this is actually what we did. We created a virtual Ethernet port on the MikroTik and assigned the speed test container onto that port. So you can imagine it as a physical port appearing, and we just plugged into something into that physical port. So this is a fully routed port, which means the traffic from my laptop, which is in this local network, to the container goes through the routing engine, goes through the firewall, goes through everything else. And we use the /31 for that, because it's a point-to-point connection to the container. Just please be aware, /31s are officially fully supported only starting in 7.18. If you're using older RouterOS, you probably don't want to do this. You want to do something else. So what is that something else? What are the other options to connect containers to my network? Well, you can just create a separate subnet, a separate bridge, and assign all of the containers to another bridge. And yeah, it's all virtual, but I mean, it's just a bridge and ports in a bridge. So in that case, we have two subnets in here, you see. So we have our LAN subnet right here, and we have our container subnet right here. And so yeah, all of the containers are within that subnet. So containers communicating between each other don't go through routing, do not go through firewall, etc. But from my LAN communicating to the containers, I would be going through routing, firewall, and everything else. So it's just another subnet on the device, nothing else. It's just another bridge and ports in a bridge. It's quite, it's the things that we are used to, just virtual, that's it. All right, so yeah, then there's a third option, actually. And the third option would be to just assign the containers directly to our local network. So just assign the containers to our bridge one, our LAN bridge. The virtual Ethernet port, it's just a port like any other on a MikroTik, so you can just assign it to the local network. So it's that easy. You have options. So pros and cons to these options. So yeah, each container in their own subnet or /31 is one way, and that's likely the best because you have the most control over the traffic. You can firewall it, there's security. One subnet for all containers is acceptable, but all containers can talk between each other without firewalling. So if there's some nefarious stuff going on, container is compromised, etc., it can talk to other containers potentially. And probably the worst from a security perspective way is to just have all containers in the main LAN subnet because there is no protection from the containers to the machines. And of course, all of the clients, PCs in the LAN subnet can get to all of the containers. So you lose that access control. Yeah, so for the rest of this presentation, we are just gonna put all of the containers into the main LAN bridge, into the main LAN subnet. This is just for convenience and time-saving purposes only. Please consider what is appropriate for your production use. Do not replicate this. This is not safe, or there is no access control here. It's just for speed. All right, so yeah, valid use case number one. So we had a nice speed test that we can run directly from our router. Yeah, in free commands. And this works from Linux, Unix, Mac, whatever, as opposed to bandwidth test. As you know, bandwidth test is a pain to get running on anything these days. So yeah, free commands on the router, and we have a speed test interface that anybody can use. Pretty nice. But for large-scale speed test deployments, and this is actually a real-life use case. So in a previous project, and this was many years ago, there was a nationwide hotel chain that wished to do speed test on each of their hotels nightly to validate if their ISPs were providing them with the sufficient connectivity to each hotel. Fairly nice use case, so it was a monitoring use case. And so I did this, again, this was 10 plus years ago. We deployed a Raspberry Pi at each hotel. So this was hundreds of Raspberry Pis that now needed to be maintained, secured, updated, replaced when broken, etc. So today, I would likely just deploy Hyper free to a container on the router. One less piece of equipment that you have to manage nationwide. So yeah, let's actually do that. Let's deploy iPerf onto our router. So we have a bunch of commands here. Let me just copy all of this. All right, copy. Go to our MikroTik, open a terminal, paste all of this in. That's it, we are done. So we see container is extracting, very good. We can check the logs, all right. Layers are being pulled, container is being pulled. We can check files, we see, oh yeah, it's being pulled and it's being put right in here. So this should finish, and it's done. Nice and fast, we just start our container. And then we go to our second bookmark, and whoa, we have iPerf. So let's run a iPerf speed test, 10.44.11.254, port 5201, TCP run test. Our IP address changed, didn't it? Yeah, 253. All right, that's fine. All right, run test. There we go, much better. All right, and we see a gigabit iPerf from the container to my computer right now. So as you can imagine, this can be very useful when you want to do these large-scale automated network speed assurance tests at night, then collect that into a database. You can notify when the speed is not being delivered as it should, without adding any additional hardware, without just 3 lines of config. Quite useful. And so if I were to do that project today, this would be a valid use case for containers I would deploy instead of maintaining hundreds of Raspberry Pis around the country. All right. Let's continue. All right, so next up, local pollers. So when you manage many disparate networks in many places, in particular when you are an MSP, you likely want a single central server and need a poller, a local poller in each of the networks. The poller will just poll data from devices locally, which are behind net, which are behind firewalls, and the server is in the cloud. And basically, this running the poller in a container means you don't have to create VPNs, you don't need to maintain connectivity, you don't have to care about dynamic IP addresses and firewalls and everything, and it will still work. So there's a bunch of this stuff. When is this useful and what we will actually deploy? Well, monitoring agents. So we will actually deploy NetXMS and Zabbix proxies inside of our local network that connect to a central server. For configuration management or automation systems, such as Unimes, for log collection, such as syslog, and for authentication proxying for Radius or Authentic. And there's many others. So let me show you. So how this works is, we have a central server in the cloud, and we will have a local container. The container will connect to the server. Here we can see that in the red. And then the container will communicate locally to all of the devices locally in the network. And so we will deploy monitoring, configuration management, and authentication proxies all in containers. And by the way, every vendor, every solution calls this a little bit differently. Some call it a poller, some call it a proxy, some call it a remote agent. Unimes calls it a remote core. Some call it an outpost. Same thing, just different names. All right, so let's go on. And by the way, this is also amazing for security because many of the essential network services are not encrypted. As you know, Radius, not encrypted. Yeah, sure, there is MS-SHAP v2 and blah, 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 but it's not encrypted. Syslog, not encrypted, right? SNMP, version 2, version 1, not encrypted, and version 3, encryption is optional. So like this adds a lot of security because we will be having a single centralized encrypted and secured session to the remote cloud server, and then all of the local polling can be unencrypted because it's in our local network. All right, so how do we do all of this? Actually, we'll start with Unimes, simply because I want to show you a lot of stuff, and doing it manually is both error-prone and takes time. So I have automated all of these deploys in Unimes. So the first thing we will do is connect our local network to Unimes, and then we will deploy all of the containers through Unimes through our routers. You don't have to do this. This is just to save time. So to deploy Unimes container and to start managing our devices, we need to somehow let the container know where is the server, what is the access key to the server, what are the secrets, etc. So how do we do this? Because we mentioned we cannot really do anything inside of the container. Well, for this, we use environment variables. So environment variables will be passed to the container, and the containerized service can then use these environment variables. Each service has their own environmental variables, so you kind of need to study a little bit. You need to learn how to deploy that service, what environmental variables they need. So let's start with Unimes. We already know this part. We are just creating a containerized virtual Ethernet interface and deploying it into our local network, into our bridge. So let's just copy that, paste it in. I have like 3 terminals open at this point, but that's fine. And so here is the example of our environmental variables. So using these environmental variables, we are just specifying our time zone. Then we are specifying a Unimes server address, Unimes server port, and a very, very secret access key that all of you can see. Don't worry, this is just for this presentation. All right, so let's copy all of that. Let's deploy all of that. Done. And then finally, we'll be deploying our Unimes container. And so while this is running, I'll paste it in. It will take like under a minute to pull, but still, let's save some time. So it's extracting, it's downloading, it's running. So the important part here is, again, like root directory, it's just our USB, remote image, all right, that's being pulled from the registry. That's our virtual Ethernet, and then here we have this environment list that we just created that we are passing these values to the container. And I enabled logging for the container just so that we can see the container logs as they happen, just so we understand what's going on. All right, so, all right, that's still being pulled. It should be finished any second now. All right, here it is. Live demo going well so far. All right, there it is. Let's start our Unimes container. All right, logs. And here we can see Unimes core is booting up. Starting. Come on, little core. You can do this. Yay, connecting and connected. All right. So I think I have a diagram here. Yeah, so basically what we just did is exactly this. We deployed our local Unimes poller, and we have our central Unimes server. So let us connect to it. Yeah, all right, it's fine. It's just our VPN. Tunnel enabled. All right, we connect to this. Come on, there we go. All right, that's much better. Yeah. Thank you. Nah, all right. Here we are. All right. Log in. All right, so we should see in zones now, yeah, our MTPC container is live. So this is a router through a container. Well, let me actually switch that. Oh yeah, that's very dark. let me do this. This might be a bit better. All right. Much better, right. So, thank you, if that's all it takes. All right, so we have our MTPC container running on a MikroTik, signing right live into Unimes. And so we should have our devices here. Let's check our MTPC zone, MTPC. Yeah, here's our devices, so we should be able to run a discovery. They were already discovered previously, but still, this should all work. We should be able to pull their config. We should be able to manage them anyway. All right, so I have prepared some automation presets, like I said, for the sake of time and consistency, and hopefully it will make the rest of the lab go as well as it has so far. All right, so we have deployed configuration management onto our network from a container. And again, you can see this would be a completely valid use case. Why? Well, because the proxy is completely stateless. It doesn't have any data. It doesn't store anything. It's just a proxy providing connectivity to the inside of the network. Completely valid use case. All right, so we can now manage all the devices in our local network without VPNs, without local servers. So yeah, and I think perhaps our discovery jobs should have already completed without an issue. Let's see, MTPC. Yeah, no errors, last jobs are alive. All right, very well. So let's continue. Okay, so how about something cool now? Let's deploy a service that will do periodic speed tests. Here, it will do a speed test every minute and then present a dashboard and show us a graphed speed test results across this presentation. So from the rest of this presentation from now on, every 2 minutes, there will be a periodic speed test to speedtest.net, and we will have a dashboard to view the graph, all running from our local router. All right, so let's see if we can do that. Oh yeah, before we do that, so now we are talking about persisting some data, these graphs, these results. They need to be stored somewhere, somehow. And we mentioned that persistency of data with containers needs to be handled somehow. So the answer to that is mounts. So we will mount some persistent storage to the inside of the container to keep the database of this speed testing service functional. All right, so how does that work? Well, as we said, we just take our USB stick and mount a location on the USB stick to the inside of the container, and therefore any data written there will be on the actual USB stick, and when we reboot or restart the container, the data is persisted on the flash drive, so it will be there. All right, so let's, again, I will be deploying this in Unimes just for the purposes of automation and consistency, but here are the commands. You can see we are deploying our networking right here. It's not big enough, is it? All right. Does that work? One more. All right, so we are deploying our networking. we are deploying some environmental variables, and these are just telling us, again, our time zone. We are storing our data in SQLite, which is a file-based database. The cache will be in a file. Here we are telling it, do a speed test every 2 minutes to a cron expression, and this is just some random app key value that speedtest.net needs. And then we have 2 mounts. So we are mounting, you can see here, the config of the speed test tracker on the USB drive, and then we are storing the database of the speed test tracker on the USB drive as well. And then we are just firing up our container. See, here is the container on the USB. Here is the image. And then we are telling it, use these environmental variables, use these mounts. That's it. All right, so I will fire, oh, wow, okay, now that's huge. All right. So let's fire this up. Go, run. So while this is deploying, let's keep the presentation going. So here is all of the config if you want to replicate this and play with this for yourself. So don't worry, I'm not leaving you dry. You can just copy all of this and it will work. And let's check if this was deployed. Yeah, it was absolutely deployed and the container is already getting pulled. Very nice. So you can see you don't have to do any of this manually. You can template it out and use any automation, any configuration management system you like to deploy this at scale into the network. All right, so let's check out our container. We will be running this presentation a little bit over time, but I validated with Lorenzo and Ron that that's okay because I want to show you a bunch of stuff. All right, so that's now running. Let's check it out. All right, here is our automated speed test. Yeah, it's there we go. All right, it just took a little bit. It's live, yeah, it's a live demo. All right, there we go. All right, so yes, I was prepared for this. So it needs a username and password, but that's fine. Here are the defaults. So we'll just copy the default username, default password. We don't care. Yeah, you can remember me. Go. No, I don't wanna. No, go away, all of the password managers. All right, so let's see. I think we can switch that to light right here. All right, let's do a speed test. Let's do a speed test to any of your guys' networks? Which one? This one? F? That's all we have for F. All right, we'll just pick one, O2 Czechia. All right, O2, go. So we are now running a speed test in the background. If we check our results, yeah, it's running, it's fine. And again, this container will continuously for the rest of this presentation do speed tests, and we will check back at the end of this presentation what internet speed Ron and Lorenzo have prepared for us. Please don't do all of your speed tests at the same time. I want to have some actual graphs here. Don't DDoS the network. All right, let's continue with something cool. So as you may likely know, Chrome and all the Chromium-based browsers in the last actually couple of months disabled ad blocking extensions because of Manifest 3. So how about let's just deploy Pi-hole, which is a ad blocking DNS server in a container on our router and transparently automatically block all the ads for our network. And actually, I have this running at home. This saves me about 10% of traffic on my network. 10% of internet traffic is just ads. So doing this has some actual benefit. And again, here is our container config. So we are just deploying Pi-hole in a container on our router. So I'll just go to my prepared automation preset here, second automation preset. Here you can see what's being done here. So yeah, we just give it an IP address, do some networking. Password will be our password. Then we just create a mount for Pi-hole config, and we deploy Pi-hole. Again, you can copy all of this. From the presentation itself. All right, run. So that is being deployed now. Container is being pulled. Pi-hole is being deployed. Let's keep on tracking. Let's do some more. All right. So Pi-hole is being deployed, so we actually need to set Pi-hole as our DNS for this network. So I have a little nice service here. Can you block it? So let's see if ads are being blocked. And they will not be because we haven't set a DNS yet. All right, come on. Yes. All right, fine. Oh my God, so many pop-ups, so many ads. Can we just, wow. Oh yeah, that's lovely. Wow. This takes an IQ of 155. Yeah. Yeah, by this. Yeah, exactly. Okay, I don't like this. Come on. This is so much crap. Let's get rid of all of this. So let's start our Pi-hole. Let's run our automation preset to run Pi-hole, to set the DNS. All right, go, run. All right, let's log in to our Pi-hole to check out if it's up. Pi-hole, Pi-hole. Password. No, I don't want to save that, thank you. All right, here is our Pi-hole. So, and you can already see, oh wow, already 26% of DNS requests are being blocked. Thank you, Microsoft Telemetry. All right, so let's get back to our, can you block it? Yes, I can, I absolutely can. And let's run a little test. And, okay, fine, there's DNS cache. Of course there is cache. Yes, we'll just empty our DNS cache, IP. DNS, cache, flush, cmd, ipconfig / flush DNS, thank you. All right, there we go. Let's see if that works. Refresh. Come on. Yes. Live demos. What is going on here? Oh, it's probably my VPN. DNS is probably going through my VPN. Let's check just to make sure that, yeah, that seems to be good. And apparently Pi-hole is receiving some requests because there is definitely 58% of blocked. Well, no, actually, sorry, 13% block list. But yeah, anyway, you can see, I won't spend time on this because we are already over time. I won't spend time on this, but you can see Pi-hole is receiving queries, things are getting blocked. Maybe let's try a simple test instead. This might be cached in the browser, of course. Yeah, that's better. That is better. There's no ads. So I think it's just cached in the browser. But yeah, there is, wait, all right, come on. No, still ads. All right, we won't debug this. But the point is we have Pi-hole running, and I think it's just my DNS is getting routed through VPN. We won't spend time on this. You can see it's running. Sorry? Yeah, it works. So yeah, that's our Pi-hole running on the router. So let's check in with our router. We have 5 containers running. How are the resources on our router? No. All right, so actually doing fairly well. We still have like 30% of memory left. So we are consuming about 700 megabytes of RAM. You can see the CPU is still at its minimal frequency, so it's just idle. It's just nicely idling. So yeah, 5 containers on a 5009 without an issue. I'm gonna stop the top 2 ones that we started with, just so we free up a little bit of memory. And let's keep on tracking. All right, so yeah, more polar examples. So I mentioned we will deploy NetXMS and Zabbix polars to the local networks. So let's do that. Again, I have my automation presets here. So let's go here. Let's do our automation. Let's deploy NetXMS. So you can see here, there's a NetXMS agent for MikroTik. I know it's small. We're just going to deploy it. Go. And we're going to deploy our 5. We're going to deploy our, no, that's authentic. Where's our Zabbix? All right, where's our Zabbix? Here is container Zabbix. Oh, yeah, this shouldn't be here. That's fine. Sorry, a little bit of live debugging. Save and run. All right, so in the meantime, we should have, all right, here is our NetXMS agent already running. Let's start it. And so here in the log, we can see that, yeah, NetXMS is starting up. You can see here all of this is NetXMS starting up, binding, and you can see it's already listening. And in the background, Zabbix is being pulled. For the sake of time, I will not show you this in NetXMS, but it's very simple. In NetXMS, I could see the router, I could see my local network. Same with container Zabbix. There it is, it's ready. Let's start Zabbix. Logs. And here is our Zabbix. You can see discovery workers coming on, SNMP cache is coming on, and Zabbix. So Zabbix is now polling our local network through this container. So again, these are very valid use cases for containers because, again, these are stateless services that just provide proxying into our local network and provide encrypted upstream to our servers. All right, so I have one more, and then we are done. Sorry. We started a little bit late, and we are running over time. I promise it's the last one. You can skip it if you like. All right, so last one I would like to show you, which is pretty cool. It's called Authentic. So Authentic is a single sign-on security system for the whole infrastructure. It provides OAuth, so OpenID, Connect. It provides Radius, LDAP. Basically, it's a single authentication system for the whole of your infrastructure. What we are going to use it for is we are going to deploy a Radius outpost, which will do authentication to our MikroTiks, and it includes MFA, multi-factor authentication with TOTP. So here is our authentic. Let me show. So I'll run this automation. And while this is deploying, I'll show you a little bit of Authentic. So how this works is I have a bunch of services here. And I'm trying to log in into my service. And oh, it's just giving us an authentic login. So I have another service here. And so actually, this is my internal certificate authority. So certificate authority, Kirnak internal. I run it. And oh, it's again asking for an authentic login. I run into Portainer, and Portainer will show me, oh, well, you should be logging in with OAuth. So all of this goes back into a single central authentication source. So, and by the way, this has very strong security. So if I log in, this actually requires my physical YubiKey, which is somewhere in here. So we need to plug in our YubiKey. We need to provide a pin to the YubiKey. Enter, we need to touch the YubiKey. And now we are authenticated into Authentic. And so you can see here, now when I try to access any of these services, which were behind the username and password, suddenly I'm just automatically logged into all of them, right? And with Portainer, we can also say just log in with OAuth, and it doesn't ask for anything. I'm just automatically logged in. So this is a single sign-on system for all of your infrastructure. It's very, very useful and very, very nice. And it can do MikroTik as well. So in the meantime, it should already be deployed on our MikroTik. So let's go to Authentic itself, admin interface. We have this prepared here for our MikroTik. So applications, providers, blah, 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 blah. Actually, we want to go to Outposts. Yeah, our Outpost, here is our MikroTik. Can you see this? No, you can't. Let me fix that. I'll just, for the sake of time, I'll just make it bigger. Is that better? All right, so here is our, no, it's not really better. Here is our MikroTik outpost. You see, MTPC, well, our conference test. So what we need from here is we just need to copy our access token. All right, oh, see, Radius is already coming in, but that's fine. We'll just go to our environment here, fix the token with a super secret token that's gonna be deleted after this presentation. And we're just gonna start our container. So we'll open our logs and see, all right, here it's doing its stuff. See, provider successfully connected to the server. So now the outpost is connected to the backend. And again, Radius is not encrypted, but I'm happy putting my username and password in there because I know the outpost is communicating through HTTPS, through TLS to the server, although the local authentication is happening without any encryption. All right, so let's try to log into our MikroTik. And it fails. And that's OK. This is because my account only has a physical YubiKey token. It doesn't have a TOTP. So it's going to fail because I cannot provide a second factor, which my login requires. But I just want to show you that here, you see, MikroTik is trying, and then Authentic is seeing this. And in the Authentic container, we are saying it's failing to execute the login flow because we aren't providing a second factor. So if I had a TOTP token, I could just plug in the numbers from TOTP in there behind the password, and it would log me in. Again, in the essence of time, I won't do this, but the point is, here is how to set up an Authentic outpost. Here is how to configure Radius on MikroTik, so it would allow for login from your Authentic to Radius. And that's it. So final recap. So when should you run something like a container on a router? Well, for debugging tools, for testing tools, for performance purposes, that's a great use case. Anything stateless providing access or convenience, anything proxying connectivity to the inside of the network is great if it's not performance limited. So you can imagine if I'm monitoring a network of 300 hosts through Unimens or NetXMS, I probably wouldn't want to deploy that on a container because I would run out of resources. And anything holding data long-term, bad. Please don't put up file servers or document servers on routers. Not a great idea. And anything critical for production, extremely bad. Don't run that on routers. Run that on actual servers. Make sure you have high availability, redundancy, backup strategies, etc. Point is, know the right use case and use the containers for the right use case. And that's it, thank you. Let's check on our speed tests before we go. All right. Yeah, there was a bunch of speed tests going through the entirety of this presentation. Let's check our dashboard. And so yeah, you can see this is speed tests running automatically on a schedule from a container in a router that you can run anywhere to present to people and to tell them, no, your internet was fine when you were telling me it was not. Thank you. That's it for the presentation.